Okay, class, today we're going to talk again about logistic differential equations, and this is part 2. And we want to know just a couple facts about this thing. Alright, so first off, I'm going to say that this is an example of a differential equation we would call an autonomous differential equation. And there's not much to know about that other than a couple things. Autonomous means it's of the form dy dx equals a function of y. Okay, so there's only one variable on the right hand side, and it's a y variable. Okay, let's just look at an example here. So dy dx equals, we'll say 3y times 8 minus y. Okay, so what's the significance of autonomous differential equations? They have what we call equilibria. Okay, that's the plural of equilibrium. They may only have one equilibrium. And this is the y values where dy dx equals 0. So let's find those in this particular equation. So dy dx is 3y times 8 minus y, so that means we would set 3y times 8 minus y equal to 0. And we're going to get two answers here. So we're already factored, so it's pretty easy to figure out. We're going to get y equals 0 and y equals 8. So those are our equilibrium solutions. There's also this thing called the phase line and phase plane, which I'll just demonstrate to you. You don't need to really know a whole lot about that. We'll talk about it again when you take differential equations, if you take differential equations. So this is a sign chart. The phase line is a sign chart. And you just look at, these aren't x values, these are y values. So this would correspond to the y-axis. And you just do a sign chart for the right-hand side there. And for us, we're going to see that we would get the signs of negative, positive, negative. Okay, so what does that mean? So we have this thing called the phase plane. Okay, so what's the deal with the phase plane? So we graph essentially our equilibrium solution. So one of them is already on there, it's y equals 0. The other one is y equals 8. Okay, these are both actually solutions to the differential equation. If you substitute 0, y equals 0 on the right hand side, you get 0, and the derivative of y equals 0 is 0. Same with y equals 8. So these are both actual solutions to the differential equations. So what we really want to know is, what do the other solutions look like? And not really what their answer is, what do they look like? Well, going back to the phase plane, we have negative, positive, and negative. And I said this corresponds to the y-axis. Negative would mean decreasing, positive would mean increasing, and negative would mean decreasing. So essentially, if I'm thinking about that sign chart right here, I get these following things. And I like to put them as arrows. So when y is less than 0, I'm going to have a decreasing solution. And between 0 and 8, it's going to increase. And bigger than 8, it's going to decrease. So essentially, all of my solutions would look something like these. Okay, now that's the sweet spot in the middle. That's the one that we normally think about when we think about the logistic equation. It's like exponential growth, like we have in the middle here, and then at some point you reach a limiting factor. Okay? And we should talk about this 8, this equilibrium solution of 8. It's got a name. This is called the carrying capacity. If you think about logistic growth is used in carrying capacity. There we go. Trying to talk and spell at the same time. If you think about logistic growth, we use it for population models over long periods of time. And over long periods of time, exponential growth is not sustainable. You end up getting, you have a limited amount of resources, and you say have a limit as to how high you can grow. So the carrying capacity refers to what that limit is. Okay? That's enough for this video.